Hello friends, continuing with the topic of electrical capacitance. Today we come to the seventh part of it as energy stored in capacitor. Now energy stored in a capacitor is given by the expression half Q square by C or half CV square or half QV, where Q is the charge stored in the capacitor, V is potential difference applied across the capacitor, and C is capacity of the capacitor. Now let us derive these expressions. First, physical situation. Consider a capacitor with capacity C connected across a source of EMF B having potential difference V through a key K as shown in diagram. When key K is closed, capacitor starts getting charged from 0 to maximum value, and the charging is shown in this graph. That's how capacitor gets charged with time. So y-axis shows charge and x-axis shows time. Now let Qt be the charge stored in the capacitor at any instant of time t such that potential difference across C is V equal to Q by C. Let us mark it as equation 1. 2. Small work done dW. Let dq be the small charge added to the capacitor in small time dt. This small charge dq will be added to capacitor against repulsive force due to charge q already present in the capacitor. Therefore, small work done dW is equal to V dq is done. Let us mark it as equation 2. This work done is negative and stored into the capacitor in the form of electrostatic potential energy. Three. Total work done in storing charge from 0 to Q can be obtained by integrating equation 2 within limits 0 to Q. Therefore, integration dW is equal to integration V dq from 0 to Q, or it is equal to Q by C dq integration 0 to Q, because we have replaced V as Q by C here, and it is equal to 1 by C Q1 plus 1 divided by 2, and it is equal to half Q square by C. So this is how we integrate equation 2, and we get the final result as half Q square by C, or W is equal to half Q square by C, because integration dW is W. So we write W is equal to half Q square by C. Now since work done is negative and is stored in the capacitor in the form of electrostatic potential energy, which is represented by U and is expressed as U is equal to half Q square by C, but Q is equal to CV. So therefore we replace Q by CV in the above expression. We get U equal to half CV square, and when we replace C in this expression as Q by V, then we get U is equal to half QV. Thus energy stored in the capacitor is given by the expression U is equal to half Q square by C, or U is equal to half CV square, or U is equal to half QV, by any of these three expressions. Now energy density of electric field in parallel plate capacitor. Now fourth, energy density of electric field in parallel plate capacitor. Let us define energy density of electric field first. It is energy stored per unit volume of a capacitor and is given by the expression U by V equal to half epsilon 0 E square. Now let us derive this expression. First we develop physical situation. Consider a parallel plate capacitor with capacity C, area of each plate A, and separation between the plates as D. such that C is equal to epsilon 0 A by D. Its volume V is equal to A into D. And let this capacitor to possess charge Q such that energy stored in the capacitor be U equal to half Q square by C. But Q is equal to sigma A. Therefore, replacing Q by sigma A in the above expression, we get U equal to half sigma A whole square divided by epsilon 0 A by D, or it is equal to sigma square AD divided by epsilon 0. Now multiplying it by epsilon 0 and dividing it by epsilon 0, we get U equal to half epsilon 0 sigma square V divided by epsilon 0 square, or it is equal to half epsilon 0 E square V, because E is equal to sigma by epsilon naught, and sigma by epsilon naught whole square, that is equal to E square. So that's why we write U equal to half epsilon 0 E square V, or U by V. We shift V to the left hand side in the denominator. So U by V is equal to half epsilon 0 E square, and is energy density of electric field. So this is how we can derive the expression of energy density of electric field in parallel plate capacitor, and it is equal to half epsilon 0 into E square, where E is electric field, epsilon 0 is the absolute permittivity of free space. Assignment 2.3. Assignment 2.3 continued. Question number 14. The plates of parallel plate capacitor have an area of 90 centimeters square each and are separated by 2.5 millimeter. The capacitor is charged by connecting it to a 400 volt supply. A. How much electrostatic energy is stored by the capacitor? B. Calculate energy density of electric field of the capacitor. You solve these two questions on the basis of the text that you have learned, and thank you so much. Next time we'll take up the next part. Till then, goodbye.